Hey guys, this is Mr. Torres again. I just wanted to go over a couple of things to help you for those of you who have not done the mastery homework yet, and also to help you study for the quest that you guys are going to have to be taking this weekend. Um, some of the things that I want to talk about again is some of those key terms that I mentioned last week. Again, these are not going to go away. These are going to keep coming over and over and over again. You need to know still how to name lines, planes, segments. Some of the things we talked about, that you use 2 points to name a line and name a segment, but you use 3 points to name a plane, and those 3 points need to be non-collinear, but they have to be coplanar. Again, non-collinear meaning on the same line, coplanar meaning on the same plane. We talked about midpoint, and we even introduced the midpoint formula this week. All these properties of equality and the properties of congruence, they're going to keep coming up. You know, we didn't test on proofs last week, so you can bet that we're going to be testing on proofs this week. Okay? All these properties, including the segment addition postulate that allows you to add two smaller segments and set them equal to a larger segment. And then we have all these formulas that we introduced this week. We have the midpoint formula, the distance formula, the partitioning formula, the slope formula. That was a review from last year. The point slope forms of an equation and the slope-intercept forms of an equation. Again, those are reviews from last year. And I want to go over some of the questions that some of you guys had problems on this week. So starting with this problem, we have segment AB. And then they're telling you, hey, if we extend segment AB through A, meaning in this direction, okay, then we and create A as the midpoint so that A becomes the midpoint. That means that the segment needs to be going this way and A all of a sudden is the midpoint. They're asking you, what are the coordinates of this new point F? Okay, well, a couple things that we need to know. We need to know the coordinates of point B, which is 1, 2, and the coordinates of this point A, which is -2, -3. And now we're going to use those coordinates to come up with the coordinates of our new endpoint F. So a couple different ways that you can do it. You can use the midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. Okay, that's our midpoint formula, and then you could set it up using that, or you can use number lines. We've been using the midpoint formulas in class the most, so I'm going to go ahead and do that form instead. So our midpoints are, the values of our midpoint are -2, -3. So I would write -2 equals, the x that I know is 1, so I'll do 1 plus x over 2. Cross multiply, I get -4 equals 1 plus x. Subtract 1 from both sides, and x equals -5. So -5 is the x coordinate of point F. So then I do the same thing for y. The midpoint value of the y is -3. And the y that I know is 2. So 2 plus y over 2. Again, cross multiply, meaning multiply by 2 to both sides. And you get -6 equals 2 plus y. So subtract 2 from both sides, and -8 is what y ends up being. So -5 and -8, which would make sense here, is a -5 and -8 is somewhere down here. That's where point F is. Okay, so that's what we would do to find the missing endpoint when you are given the midpoint. If they just give you 2 points, like if they say, hey, find the midpoint between segment AB, then you would use these 2 points with this formula to come up with the answer. Okay? Some of the other questions you guys were asked to do had to do with distance. Okay? Consider a triangle with these vertices. So let's say that we had a triangle, and the triangle had those 3 vertices. Okay? S, A, N. Alright. And they're saying, hey, what is the shortest side of the triangle? Well, what do we have to do? We have to use the distance formula to find the length of segment SA. Then use the distance formula to find the length of segment AN. And last but not least, use the distance formula to find the length of segment SN. Okay, and that's what we did down here. Okay, same problem. Again, you have that triangle, and they found the length of segment SA to be 7.2, the length of segment AN to be 7.6, and the length of segment NS to be 7.1. So using the distance formula, again, the distance formula says D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's how we found that problem. Then the next type of questions that we had was, hey, if I give you a problem, can you find me, if I give you 2 points, can you find me the point that partitions that segment? So for example, point A has coordinates 7, 2. Point B has coordinates 2, -10. Find the point P that partitions that segment into a ratio of 5:1. Today we went over in class 2 different formulas. One used M and N. Okay, the other one was K. Most of you guys seem to like this one better, so that's the one I'm going to go over. Okay, and I believe it said M times x2 plus N times x1 all over M plus N. Ooh, that's not what I meant to do. All over M plus N. And then Y, excuse me, M times Y2 plus N times Y1 all over M plus N. Okay, so what's M and N? M and N are 5 and 1. So I would have 5 plus 1. 5 plus 1. And then here is x1, y1, x2, y2. So then we would go with, okay, so x2 is 2, m is 5, so I have 5 times 2 plus 1 times 7, which is my x1. And then I have 5 times -10 plus 1 times 2. So from there, we would have to simplify this. Okay, 5 times 2 is 10. 1 times 7 is 7. 5 times -10 is -50. 1 times 2 is 2. So 5 plus 1 is obviously 6. So we have 10 plus 7 over 6. And then we have -50 plus 2 over 6. Okay, so my answer is 17 over 6 and 48 over 6. And then 48 over 6 gives me 8. It's a -48, so it's a -8. And I have 17 over 6, that's my other answer. Again, that was using the partitioning formula to find the point that partitions the segment AB into a ratio of 5:1. And then the last type of a question that I want to go over is one like this one. It says, given the points 4, 3 and -2, -5 are on the same line, write the equation for the line in point slope form and slope intercept form. Well, all I'm given is 2 points. In order for me to write an equation, I need 2 things. I need a slope and I need a point. A point I have. I can just use 4, 3. But the slope I don't have. So I actually have to use both my points to find the slope first. So I'm going to use the slope formula. Again, the slope formula should be y2 minus y1 over x2 minus x1 to find my slope first. So -5 minus 3 over -2 minus 4 gives me a -8 over a -6. The negatives cancel, and 8 over 6 reduces into 4 over 3. So my slope is 4 over 3. So now, with that, I can write my equation. And then, so that is in point slope form. And then if we simplify that and get it to say y equals something, then it would be on slope-intercept form. So when I distribute that, I get y minus 3 equals 4 over 3x minus 16 over 3. And then I'm going to add this 3 to the other side. And then I end up with y equals 4 over 3x minus 16 over 3 plus 3. And again, 3 is the same thing as 9 over 3. So because I need a common denominator to be able to add those or subtract them in this case, then that's what I did. And then that's going to give me y equals 4 over 3x minus 7 over 3. And that's the equation, guys. Again, all you need to study for this week's mastery assignment, well, it's not all you need to study, but these are the new concepts that you need to know for the mastery assignment. But please understand that proofs are going to be a part of it. Proofs are going to be a part of it. Probably the quest this weekend as well. So make sure you're studying your properties, and you don't forget the definitions and how to name lines, planes, and segments and rays. Okay. Good luck. You guys have a good day and have a good weekend.